Okay, I'm going to run through the review packet. It's going to look a lot like your test. You'll get all the equations. Everything will be given to you up here. Okay. Speed of light, c, 3 times 10 to the 8th. They want a wavelength of light. They give you the frequency. So use your equations, light equation, c equals lambda times mu. You want to solve for frequency, it's for wavelength. So c over lambda mu. So it's 3 times 10 to the 8th divided by 1.2 times 10 to the 13th. Okay. And I believe that should be around 2.5 times 10 to the negative 5th. Don't forget your units. It's meters per second divided by 1 over seconds. So 2.5 times 10 to the negative 5th, and the units are meters. Okay. I won't pull any tricks on you. Try not to. So if you get anything tricky here, it's not going to be on the test. Test's going to be much more straightforward. Make sure you learn how to, if I put this on my calculator, I get numbers. So you want to hit on a TI2, the scientific engineering buttons here. You want to go second function and then hit science and go over to science. And here's your scientific notation. I don't know if this is showing up well. 2.5, and then you'll see times 10 to the negative 5th. If you want to go back to normal, you got to shift and go back to flow. And then you'll go back to normal. Most of these you want to have scientific notation on. Again, what is the frequency? C equals lambda times mu. I want to solve for mu. C over lambda. Okay, so I got 3.0 times 10 to the 8th, that's a constant, divided by 0.53. Okay, so you got 3 to the 8th divided by 0.53. And then again, I want to have all my scientific notation. So 5.66 times 10 to the 8th. And the unit, meters per second, divided by meters. So your unit's 1 over seconds. The answer is A, 5.66, round off to 5.7. Okay, which has the shortest wavelength? On your spectra, the shortest wavelength would be X-rays. Highest frequency for shortest wavelength. Given a frequency, what's the wavelength of light? Now it asks for it in nanometers. So I'm going to use a light equation, C equals lambda times mu. I'm going to solve for lambda, C divided by mu, 3.00 times 10 to the 8th meters per second. Meters will still be there, divided by seconds. So 3.22 times 10 to the 14th, 1 over second, and the second cancels out, leaving you with meters. This isn't the answer yet. 3 to the 8th divided by 3.22 to the 14th. Now I got 9.32 times 10 to the negative 7th meters. Now you want to be able to use dimensional analysis and go to nanometers. And you should know your conversion that 1 times 10 to the 9th nanometers equals a meter. So your wavelength ends up equaling 932 nanometers. A. Okay. What's the wavelength of a photon that has an energy? Okay. I want to go from energy to frequency to wavelength, one step at a time. So I'm going to use Planck's equation, delta E equals hv. Given the energy, I want to find the frequency, so frequency equals delta E divided by h. Plug my numbers in, show my work. 5.25 times 10 to the negative 19th. H is a constant, which is given to you 6.63 times 10 to the negative 34th. So you got 5.25 times 10 to the negative 19th divided by 6.63 times 10 to the negative 34th. Okay, this energy is joules, and you could say joules per atom, but when we're doing these calcs, we can just say joules. The joules will cancel. You get a frequency of 1 over seconds. So your frequency is 7.92 times 10 to the 14th waves per second. And then the light equation, C equals lambda times mu. And then lambda equals C divided by mu. So 3.00 times 10 to the 8th meters per second divided by 7.92 times 10 to the 14th, 1 over seconds. Your answer comes out to be meters times 3 to the 8th. 3.79 times 10 to the negative 7th meters. And I think that's a little wavelength. Purple is around 400 nanometers. Red is 750 nanometers. So you're around, you could probably start perceiving around 350. So you're in the violet region and close to being ultraviolet, passive violet. Okay. And the answer was A. Okay, what's the energy of a photon that has that wavelength? Now I'm just going backwards. I'm going from, where did I write my little note? Now I'm going from wavelength to frequency to energy. So I use the light equation, C equals lambda times mu. I'm going to now solve for mu. Mu equals C over lambda. So I got 3.00 times 10 to the 8th meters per second divided by 9.0 meters per second, or just meters. So your answer is okay. Now I got 1 times 10 to the 8th. Now that's a unit of 1 per second. That's a unit of frequency. But it wants the energy. So the delta E is equal to Planck's constant times V. So I'm going to take Planck's constant, 6.63 times 10 to the negative 34th. I'm going to multiply it by 1.0 times 10 to the 8th. Okay. And so times 6.63 to the negative 34th. And my choices are on here. 6.63 times 10 to the negative. I'm getting 26. So maybe I just made a quick mistake. Go back, check my math. 3 to the 8th divided by 9. Oh, yeah, that wasn't right. This number should be 3.33 times 10 to the 7th. So now I'm going to plug it into Planck's equation times 6.63 to the negative 34th. And I get the answer is A, 2.2 times 10 to the negative 26 for 7. Keep rolling. Okay. Now again, we're going from frequency to delta E. So really easy. Just plug it in and chug. E equals HV. So H is 6.63. Show your work. The unit is joules times second. And you're going to multiply that by the frequency given. Sorry. I want to solve for the frequency. So V equals delta E over H. So I'm going to divide by 6.63 times 10 to the negative 34th joules. And the energy is given to me as 3.7 times 10 to the negative 18th. And this is 1 over seconds. And this is joule time a second. Sorry, that's joules. So the unit comes out to be 1 over seconds. So here I get 5.58 times 10 to the 15th. That rounds off to 5.6 times 10 to the 15th A. Alright, again, here's a wavelength. So now I want to go from wavelength to frequency. Wavelength to frequency to delta E. So I'm going to use the light equation first. C equals lambda times mu. Given lambda, find mu. So mu equals C over V, lambda. So 3.00 times 10 to the 8th meters per second divided by 12.3 meters. So I got 3 to the 8th divided by 12.3. This answer is 2.44 times 10 to the 7th. And the unit here comes out to be 1 over second. And then the energy is V times H, or HV. So it's going to be 2.44 times 10 to the 7th, 1 over second, times Planck's constant, 6.63 times 10 to the negative 34th, joule times second. The second cancels out, you end up with strictly joules. So delta E, and we could say joules per atom or joules per photon. So 2.44 times 10 to the 7th times 6.63 times 10 to the negative 34th, 1.62 times 10 to the negative 26, and it's joules. I'm off by 1. 3 times 10 to the 8th divided by 12.3. The energy of a photon. I'm getting for this one 1.62 times 10 to the negative 26 joules. Let me just see why that is. .44 times 10 to the 7th. I'll just take E and I'll say that should be negative 26, because that's the only one with 1.62 in it. There's a problem with 9 that I see. Okay, this one, don't look for anything like this on the test. A mole of photons has a wavelength of 725 nanometers. How many kJoules does it have? Okay, So I'm going to go from wavelength to frequency to energy. But my unit in energy is going to be joules per photon, per one photon. So let's rock with it. C equals lambda times frequency. So nu equals C divided by lambda. Now this is in nanometers, so I'm going to take that 725 nanometers, convert it to meters. So 1 meter is 10 to the -9th nanometers. So it's 7.25 times 10 to the -7th meters. Okay, so I got 3.00 times 10 to the 8th divided by 7.25 times 10 to the -7th meters. Meters should be the same, so 3 to the 8th divided by 7.25 to the -7th. I must be getting tired. A lot of mistakes. I hit a decimal instead of a negative. It's hard to see because I'm getting a reflection off my calculator. Frequency equals 4.14 times 10 to the 14th, 1 over seconds. And so delta E is equal to HV. So 6.63 times 10 to the -34th. That's joule times second. Times the frequency, which is 4.14 times 10 to the 14th. The 1 over second will cancel out. So delta E equals you're not done yet. The answer is negative 2.74 times 10 to the -19th. Now, those are joules per one photon. So I want to take a joule, 1,000 joules, and convert it to a kJ, because they want the units to be in kJs per mole. And the second thing I want to do is change my photons into moles. So you had problems like this on the dimensional analysis part. I'm going to divide it by 1,000 and then multiply it by, this is Avogadro's number, 6.02 times 10 to the 23rd photons per 1 mole. And what I get is I get an energy of 165 kilojoules per mole. And there's your 165 kilojoules for number 10. In the Bohr model, they don't move in circular paths, not like planets. The electrons can have any energy. The energies are quantized. They're not they're not controlled by probability, because in the Bohr model they're called orbitals. So I'd say both. I would just say C. They're quantized. Okay. They can't have any energy because they can't be in between two levels. Okay. So, and then the trick question to this is that's called orbit. Oh, I'm sorry. This does say orbitals. In the Bohr, we're not thinking of orbitals. We're not thinking of regions. It's not Schrodinger. So we can say circular Pascal's orbits. Okay. N2 to N6. Okay. This is going down from energy 6 to energy 2. So it's a release of energy. So it's going to be not an emission. It's going to be one of these two absorptions. Okay? You find energy 2, then you find energy 6. Use Bohr's equation, negative 2.18 times 10 to the negative 18 divided by n squared. So this will be divided by 4. The other one will be divided by 36. So negative 2.18 times 10 to the negative 18th divided by 4. This one you get 5.45 times 10 to the negative 19th. Your answer is in joules. And then times 4 divided by 36. This one's going to be negative 6.06 times 10 to the negative 20th joules. You're going to subtract these two. So that'll change to a positive. This will be a negative. So I'm getting E from 2 to 6. Energy should be 4.84 times 10 to the negative 19th joules. And because it's going up, it should be a negative amount of energy, which it is. So that's absorbed. Now, this is in joules, so now I need to go from energy, a lot of work here, to frequency, to wavelength. So frequency equals delta E over H. So 4.84 times 10 to the negative 5th divided by 6.63 times 10 to the negative 34. Unit's going to end up being 1 over seconds. So you got 4.84 to the negative 5th divided by that should be to the negative 19th. My bad, I saw that 5 there. Then divided by 6.63, negative 34. That gives me 7.30 times 10 to the 14th. Now I need to go from, let's do it over here.